Hello, my name is Alan Ivan, and my student ID is AM008511040. And this is the presentation for the second assessment on intelligent sensing for robotics at Middlesex University. As part of this assessment, we were required to provide a robotic system able to recognize cards, more specifically their colors and numbers. For who doesn't know, Cards is a card game in which cards are in 4 colors: red, green, blue, and yellow, and they are numbered from 0 to 9. In addition to the 0 to 9 cards in 4 colors, for each color there are 3 special cards, which is a double card sign, a double arrow sign, and a null sign. The robotic system was a computer and a camera that was able to capture image data and live stream. The code structure was laid onto 3 files: main file, image processing file, and augmentation file. The augmentation, as the name implies, provided augmented data for the model training and testing. The image processing was processing each frame or image from file, providing contours, crops, and card information ultimately to be outputted to the user. The main file provides the menu and the 2 functions that will run the process with images from file or from the live stream. Data methodology in machine learning was designed such that the model is using augmented data, and the running application and the live stream application, the running from file application and the live stream application are using separate data, more specifically images from file or a frame from camera stream. The 2 models of the machine learning were k-nearest neighbors, and one is for colors and one for numbers. The training and testing results were in excess of 90% accuracy, and that's pretty much it. The augmentation of colors is providing the models with over 5,000 images. It's a 2x2 pixel crop. It's 2x2 pixel color image crop. It's adjusting the brightness in HSV, and it does that within a factor range of 0.7 to 1.3, and it applies on hue and saturation. The number of augmentation also provides over 5,000 images to the model, and it's a 150 by 150 pixel binary thresholded image, and it benefits of various augmentations such as rescale, rotation, zoom, noise, and the values that are provided are random within a specified range. And in the right, you can observe the augmented data. The process sequence starts with a real image from file, and then it rotates the image, then it gets the 2 crops required for color prediction and number prediction, and then it provides a final image in which card data is added and the contours. Within the live stream, the process it's almost the same in a sense that it uses the same functions for rotation, for cropping, for prediction. However, instead of plotting a final image, it provides a live stream in which a surrounding box rectangle, a contour before rotation, and a contour after rotation is provided for enhancing understanding of how the system works. Time for demonstration. This is the main file. We got live stream and read from file functions. We got a menu. Here we got augmentation. We have the noise. We get the color augmentation. Here is the final function for noise because we use a data generator for noise. Image processing has a few helpers such as get contour, get threshold, get crops, which is providing all the crops, get rotated frame, which rotates the frame, print data, which is plotting data, the two prediction functions for color and number, and the main processing function that will return the car data, which calls the above functions and then draw onto the real image and returns it along with car data. We also have the train models, which handles the machine learning. These calls the functions from the augmented file in order to generate augmented data and then train and test the models more exactly, one for color, one for numbers, and displays the results. When we run main, we can see the models are initializing. We can already observe 5,000 color images have been loaded, generated, and another over 5,000 are being generated for numbers. After the image generation, some samples will get displayed in order for us to see how the image is augmented within the process. And observe the color variations in the augmentation and the number variations in the augmentation. Again, this is a sample for enhancing understanding. DML results are in excess of 90%. The colors perform better because it's maybe easier to perform. The number seems to be a bit more difficult with a lower but still enough accuracy percentage. In the menu we got read from file and live camera stream, the two options which we will try. Data capturing is for development, so we will not use that. Let's start with reading from file. We will not read all the data, however, we will select individual cards in a strategic way. More exactly, we will start by comparing 6 and 9 on, say, the red color. Red 6, and we can observe the initial image, the rotated image, and this is quite straight and the rotation cannot be clearly observed, but this will be better observed in the live stream. Then we got the card crop, the color crop, the number thresholded crop, and the final result. Let's do the same for red 9. So we got the red 9. Then we can do a 3 versus 8 because they're quite similar. Let's try green now. Green 3. Yeah, so we got the 3 green. Then let's try green 8. Yeah. Then we can do a 0 versus null because the numbers there are quite similar. We will do it on yellow this time. Yeah, 0 yellow and yellow null, and as in null. So we got a null yellow. We can do one more comparison. We'll do it on the blue, and we will compare the arrow, A as in arrow. And we will try to see also the double, the two little cards, the double cards. Yeah, double blue. So with images from file, the system works quite good. There are some inconsistencies resulted from bad contours. One example is yellow 6 of for yellow 6, the contour gets detected as being the ellipse surrounding the number 6, and the ellipse gets rotating, resulted in an error. And to protect from crashing, the system will not run subsequent image processing. Reason why only the first, only this image is displayed. Now let's run a live stream. I will have to stop my camera to avoid collision with the camera indexes. Let's place the first card. So we got a 1 blue. Let's see if it gets detected as a 1 blue. Yes, it gets detected. We can observe the number crop. It's not as similar as the number crop from the real images or the augmented images. And we will run into some issues in terms of live streaming. Because inconsistencies with crops, with lights, and various noise. We will try to compare number 7 now across different colors. So we got a 7 green, then we can compare with 7 red. Yeah. I believe I can, yeah, we can observe the rotation of the card better this time in the little plots. And we can try the 7 yellow as well. We can observe the yellow color is detected, although the crop for the yellow color, it's not really on yellow, but more like in range of on yellow. So that means our color augmentation, it's taking effect. There are some inconsistencies with the crop in a sense that if we rotate the card, it will still crop, hopefully on number 7. No, it's cropping on the ellipse. Now it's cropping on the 7. It still detects as a 7. However, if, for example, we move it here in this position, it will probably provide a different crop. No, this time it's a good crop. But if we move it here, let's see. Yeah, this time it's a bad crop apparently. Yeah. So in terms of card crop, there are a few inconsistencies. Then in terms of color crop, there are a few inconsistencies as well. The system is far from perfect. If we change the light conditions, because the small difference between green and yellow color spectrum, if we change the lighting conditions, now we can we have issues in detecting the green color, especially because this type of green, it's on the camera, it cannot really gets observed. It's like a yellowish green. Yeah. Other than that, let's try red on increased light conditions, and then let's try yellow on increased light conditions. We can stop this and discuss the results from the testing. So from the file, the colors have been detected 100%, 52 out of 52. Um, and the numbers in testing have been identified almost 100%, more exactly 48 out of 52. In the live stream, there is a small gap between green and yellow. It doesn't always take effect, so it's either 3/4 or the whole data set. In terms of numbers, there is quite a low accuracy, more exactly under 10 numbers out of 52. There are inconsistencies in card and number crop, which can be resolved with further research. In conclusion, the current status is that we separate machine learning data from real testing in demonstration. So we got one set of data for training, testing, and another set of data for demonstration to highlight potential issues and drive solutions for improvement. We got the high accuracy rate with images from files and low accuracy in a live stream due to variable conditions. We got a few issues which are inconsistency generated by the environment, light, color spectrum, noise, camera zoom, quality, processing time. This can be concluded to the fact that computer vision seems to be reliant on machine learning in a sense that we need to provide similar data to the real one, to the machine learning, in order to make it performant, but we also cannot make it without it because of continuous changing conditions and variables within the real environment. The training data, augmented or not, needs to be similar to the application data. Further work would include generating training augmented data from live stream snapshot rather than the images from the files. That can improve number recognition and resolve the crop and the contours issues, and define color spectrum ranges for every color to ensure better separation between green and yellow. That was it. Thank you very much for listening. I hope this was interesting and you have enjoyed it.